its nucleus here. Then in that case, the result obtained will explain the atomic model. We will see how it is going to explain. In this experiment, Rutherford and his students have taken a source of alpha particle which is bombarded on a thin gold foil on 100 nanometer. To the next, we will not able to see the alpha particle. Therefore, a fluorescent material that is, this one is of ZnS. This ZnS fluorescent material will show the presence of alpha particle. How? When this alpha particle strike this ZnS, then they will produce bright spot. This bright spot indicates the presence of alpha particle on ZnS zinc sulfide screen. Let us see what is the experiment. Let us see what were their observations. What is the experiment condition? We have a source of alpha particle, that is radioactive source. The beam is collimated. Collimated, it means it is in a definite direction and it is allowed to fall on the gold foil of 100 nanometer. Then what were his observations? He observed that most of the alpha particle moves undeflected. It means there is not deflection. The first one. The next one is that few alpha particles deflected to certain angles. And the next one, very few, that is 1 in 20,000. If we have used 20,000 alpha particle, then in that alpha particle, one of the alpha particle is bounced back. What is the experiment? Observation. Observation of alpha particle scattering experiment. The first one, most of the alpha particle moves undeflected. The next one, some alpha particle deflected to certain angle. And the third one, few alpha particle bounce back on the same path. What were his observations? He observed that most of the alpha particle pass undeflected. How he know that most of the bright concentration are produced here? Because most of the alpha particle pass undeflected, they move through this gold foil and they reach the zinc sulfide screen here. It means here what he observed the maximum concentration of bright spots, and the maximum concentration of bright spots here indicates that the maximum number of alpha particles or the alpha particles strike here. Why this is so? Because they move undeflected. When they move undeflected, they are here and the bright spots are produced here, which indicates that most of the alpha particles moves undeflected. Few of the alpha particles are found here and found here. some alpha particles are found here and here. It means they are deflected to certain angles. Whereas few alpha particles are there, and I have explained few alpha particles bounce back on the same path. They are about 1 in 20,000. It means if we have 20,000 alpha particle, then in that case only one alpha particle will bounce back. How we will know the presence of, how we will know that one alpha particle is bounced back? Because in this position where the alpha particle is bounced back, we haven't bright scintillation. It means the absence of bright scintillation in the zinc sulfide screen at a certain position indicates that at that position this alpha particle hasn't struck. If it hasn't strikes on that screen, it means it has bounced back. Let us see why this observation we have. We know if the gold foil is there, then in that case gold foil is made up of atom. Let us see here. This one is this one is the atom. This one is the next atom. This one is the nucleus. The first observation, most of the alpha particle moves undeflected. Why this is so? Because if this we assume this one to be the magnified image of this gold foil, these are the atoms of the gold foil. See here, we have taken only one row of atom. Why? Because gold foil is thin and it is in atomic dimension. If we have such one more atom here, then in that case the result obtained were not correct, and we will not, and he is not able to define the atomic structure. Then in order to do so, he take a thin gold foil. Let us see. When alpha particles are bombarded on this gold foil, what are the observations? Let us see. If we assume this one to be the one alpha particle, then it moves undeflected. This one is, we have ZnS fluorescent screen. If this one is the next alpha particle, then it moves undeflected. If we have the next one, then this will be deflected to certain angle. Because it moves, this one is positively charged and this one is positively charged. Positive repulsion, therefore it is deflected to certain angle. The next alpha particle. This alpha particle, it is positively charged, this nucleus is positively charged, therefore it will bounce back on the same path, or we can say it has a deflection of 180 degrees. So the next we have, this alpha particle passes through the positively charged nucleus, therefore it is deflected to certain angle. Next to that, it will pass undeflected, it will pass undeflected, it will pass undeflected, it will pass undeflected, it will pass undeflected. The next, it also moves near the positively charged nucleus, therefore it is deflected to certain angle. The next, it collides with the positively charged nucleus, therefore it will bounce back on the same path. The next we have, it will be deflected to certain angle, undeflected. These were the observation of Rutherford. Why these observations were obtained? This is so because of this reason. It means when the alpha particle moves through the empty space of the atom, then it moves undeflected. To the next, when the alpha particle collides with the nucleus, though the alpha particle is positively charged and the nucleus is positively charged, then in that case it bounces back on the same path. To the next, few alpha particles are deflected to certain angle. This is so because they move through positively. They move near the positively charged nucleus. Therefore, they are deflected to certain angle. On the basis of observation, Rutherford made certain conclusion, and I have discussed. Let us discuss it. On the basis of Rutherford observation, he made his conclusion. Which are as follows. Which are as follows. The first one. What were the first observation? That most of the alpha particle moves undeflected. Why they move undeflected? Because most of the space in the atom is empty. If they move undeflected, then they show that they are not going to collide with any kind of particle. If they are not going to collide with any kind of particle, then they will move on the straight path and will strike straight on the zinc sulfide screen. This indicates that the most of the space in the atom is empty. The first one, most of the alpha particle moves undeflected. This is so because most of the space in the atom is empty, and if most of the space in the atom is empty, then in that case most alpha particle moves undeflected and strike on Zn as screen. So the next we have a small fraction of alpha particle which are deflected to certain angle. Let us see here, this one, this one, this one and this one. They are deflected to certain angle because they pass near the positively charged species. Therefore, because of repulsion with the positively charged species, they are deflected to certain angle. The next one, a small fraction a small fraction, this and this. Fraction of alpha particles are deflected to certain angle. This is so because they pass near from positively charged spaces, and when they pass through the positively charged spaces, though the alpha particle is positive, it means they have positive repulsion, therefore they are scattered to certain angles. They pass near from positively charged spaces, therefore they pass near from the positively charged spaces, and because of repulsion, they are deflected to certain angle. The next, a very few alpha particles, that is 1 in 20,000. They are bounced back, it means they are deflected to 180 degrees. They are bounced back on the same path because they collide with the positively charged spaces. The next one, a very few alpha particles, that is 1 in 20,000, bounce back on the same path because of collision with positively charged spaces. Based on this calculation, he has inference, and the inference was that though a very few particle 1 in 20,000 bounce back on the same path because it collides with the positively charged nucleus, and its dimension was quite small in comparison to the dimension of the atom, because when we bombard 2,000, 20,000 alpha particle, one particle is bounced back. Why it bounced back? Because it has head-to-head collision with the positively charged species, and that positively charged species, which is in the center, it is nucleus. The next, most of the alpha particle moves undeflected. It means at the center there is nucleus, and around the nucleus there are electrons, right? But the most of the alpha particle moves undeflected. This is so because most of the space in the atom is empty. On the basis of this experiment observation and this conclusion, he come to state the atomic model. On the basis of experiment observation, Rutherford made conclusion, and on the basis of that he proposed the atomic model, which is as let us discuss. On the basis of experiment observation and conclusion, Rutherford proposed atomic model. Which is as follows. According to Rutherford's atomic model, the positive charge, that is proton, together with the mass is densely concentrated in a small portion at the center of the atom, that is termed as nucleus. The next, the electrons are revolving around the nucleus in orbits, which is synonymous to our solar system, in which the nucleus is synonymous to the sun and the electrons are synonymous to the planets. The next is that the electrons are held together with the nucleus by the means of strong electrostatic forces. What are these? Let us know. The first one, the positive charge that is protons, and most of the mass of the atom is concentrated in a small portion, a small region at the center of the atom, known as nucleus. What we have? The positive charge together with the most of the mass of the atom is concentrated in a small region at the center of the atom, known as nucleus. The next we have the electrons are revolving around the nucleus in fixed path around the nucleus in orbits.